Hello everyone, welcome. This is part 6 of playing. So if you haven't watched part 1 to part 5, so go through that. So in part 6 and part 7, what we're going to do is we're going to do some additional problems, right? So we're going to do 7 problems overall in part 6 and part 7 combinedly. So in this video, we're going to do 5 problems and in the next class, we'll be doing the remaining 2 problems, right? After finishing these 7 problems, we'll moving on to the next subtopic in planes, right? So all these 7 problems are very, very important. So all are miscellaneous problems that is based on part 1 to part 5, right? So we'll directly get into the problem. So all the problems are very, very, very important, right? First problem is a variable plane at a constant distance p from the origin meets the coordinate axis in a, comma, a, b, and c. Through ABC, planes are drawn parallel to the coordinate plane. Show that the locus of the point of intersection is x power minus 2 plus y power minus 2 plus z power minus 2 is equal to p power minus 2. Right? So I'll just draw a very, very rough diagram because if I draw diagram, it will be easy for you to visualize. But it is very hard to draw a 3D diagram in 2D surface, right? But I'll draw a very, very rough diagram. So what we have is a variable plane is at a constant distance p from the origin. That is the distance from origin to the plane is p, right? So this p is any number, right? Okay. So let us draw some coordinate plane. Let this be x-axis, let this be y-axis, and let this be z-axis. Let us draw a plane. Let us draw a plane, right? Let this be the plane. So it meets the coordinate axis at A, B, and C. That is what they are given, right? A variable plane is a constant distance p from the origin. That is, the distance between origin to the plane is p, right? I'm not writing here. So I'm not marking here, right? Okay. A variable plane is at a constant distance p from the origin, meets the axis in A, B, C. Let this be A, let this be C, let this be C, right? Okay. Now, through ABC, planes are drawn parallel to the coordinate plane. Now, through ABC, we need to draw a plane that is parallel to the coordinate planes, right? So, that is XYZ are coordinate plane. So, through ABC, I'm going to draw a coordinate planes, right? So, this is one plane, right? I'm just drawing a very, very rough diagram. So, through B, I'm drawing a plane, right? That is parallel to the coordinate plane. You can say this is parallel to this coordinate, and I'm drawing through A. I'm drawing another plane that is parallel to the coordinate plane. You can see it's parallel to Y. And through C, I'm drawing another parallel plane. Right, another parallel plane. Right, I'm just drawing very, very rough diagram, right? Okay. So through C. So through A, through B, through C. Now you can see it meets, this is the point of intersection, right? This is the point of intersection. Now we need to show this point of intersection x comma y comma z satisfies this equation, right? The locus of this point satisfies the equation x power minus 2. That is, locus is x power minus 2 plus y power minus 2 plus z power minus 2 is equal to p power minus 2, right? So it is at a constant distance p from the origin, right? If you take distance to be equal to 2, we have a point p somewhere. Right. If okay, let us call this point as Q, right? Because we have already used the distance P from the origin. Let's take this point. In this point of intersection is Q, right? Suppose if the distance is 2, right? That means you will have Q somewhere. If the distance is 3, you will have Q somewhere. The distance is 4, you will have Q somewhere. But even though Q may somewhere, but the coordinates x comma y comma z will satisfy some equation. That equation is x power minus 2 plus y power minus 2 plus z power minus 2 is equal to p power minus 2, right? So depending upon the value of p, the q point will vary, right? Q point will vary. But even though the point may vary, the coordinates, the set of coordinates will satisfy some equation that is called locus, right? What is locus? In the previous class, I had said locus is locus is an equation that a set of points will satisfy, right? Here, a set of points will satisfy the condition that whatever point you take, right? That is all the point of intersection satisfies. It is a distance of p from the origin, right? Okay, and also it is parallel to the coordinate plane, right? Good. Okay. So we'll start the solution. So let the variable plane be. So let the variable plane be x by a plus y by b plus z by c is equal to 1, right? Let this be the variable plane. X by a plus y by b plus z by c is equal to 1. Now it meets the coordinate axis at ABC. Now what is the vertices of ABC? Very easy, right? So it is given that it meets the coordinate axis. It meets a coordinate axis in A, B, and C, right? So clearly, you can see the x-intercept is A, y-intercept is B, z-intercept is C. So obviously, what is the point? What is the coordinate of ABC? A is A, comma 0, comma 0. B is 0, comma B, comma 0. C is 0, comma 0, comma C, right? So it meets the coordinate axis in ABC. Clearly, the vertices are, so A must be A comma 0 comma 0. So B must be 0 comma B comma 0. And C must be 0 comma 0 comma C. This is the required vertices, right? If not, if you want to find x-intercept, put y is equal to 0, z is equal to 0. So this will get 0, this will get 0. So we have x is equal to A. If you want to find y-intercept, put x and z to be equal to 0. You will have y is equal to B. If you want to find z-intercept, put x and y to be equal to 0. So this will get 0, this will get 0. So we have z is equal to C, right? Clearly the vertices are, therefore this point is A comma 0 comma 0. This point is 0 comma B comma 0. This point is 0 comma 0 comma C, right? Point is, this is capital C, this is small c. This is capital C, right? This is capital C. Okay. So this is the vertices, right? Okay. Now it is given that a variable plane is at a constant distance p from the origin, right? So it is given that it is at a distance of p from the origin. It is given that, so it is given that, it is given that it is at a distance, is at a distance of p from the origin, right? So that is the perpendicular distance. If they haven't mentioned, right, you always take the perpendicular distance. That is the perpendicular distance from origin to the plane is P, right? What is the perpendicular distance formula? What is the perpendicular distance formula? Very simple, right? The perpendicular distance D is given by, perpendicular distance P is given by minus D divided by root of A square plus B square plus C square, right? This is the perpendicular distance formula, right? Perpendicular distance from origin to the plane is given by this formula, right? We already discussed, right? Okay. If you want, I can write it. We know that the perpendicular distance from origin to the general equation of the plane ax plus by plus cz plus d is equal to 0 is given by p is equal to minus d divided by root of a square plus b square plus c square. I have already said that make this d always to be negative. If it is not negative, means you multiply throughout by minus, right? We have already solved these kinds of problems. Now we know that the perpendicular distance from origin to this plane is p, right? So, you apply the same concept here. So therefore, the perpendicular distance from the origin to the plane 1 by ax, right? Ax plus by plus cz plus d is equal to 0. This is the now plane, right? Ax plus by, it is an intercept form, but we just compare this with in general form. We have a to be equal to 1 by a, b to be equal to 1 by b, c to be equal to 1 by c, d is minus 1, right? So this perpendicular distance given by minus of d is minus 1 divided by root of a square plus b square plus c square, where a, b, c are coefficient of x, y, z, and it is in normal, right? Okay. This will be 1 by a whole square plus 1 by b whole square plus 1 by c whole square, right? So therefore, the perpendicular distance p is given to be 1 divided by, so therefore we have p to be equal to 1 divided by, right, 1 divided by root of 1 by a square plus 1 by b square plus 1 by c square, right? This implies, what about the value of 1 by p square, right? Okay, first we find p square. What about p square? The root will get vanished. So we have 1 by a square plus 1 by b square plus 1 by c square. This implies the value of 1 by p square is given to be, just reciprocate 1 by a square plus 1 by b square plus 1 by c square. Call this as equation number 1, right? Okay, let us call this as equation number 1. This is a required, this is the variable plane. Let us call this as equation number 2, right? Call this as equation number 2, right? So what we have so far is, it is given that we have a variable plane. It meets a coordinate axis at ABC. So from that data, we have found the vertices of ABC, which is A00, 0B0, 00C. After that, we have used the condition that the distance, the perpendicular distance from origin to the plane is P, right? Therefore, we know the formula for perpendicular distance. It is given by minus t divided by root of a square plus b square plus c square, where ax plus by plus cz plus t is equal to 0 is general equation of plane. Therefore, we know the distance, perpendicular distance from origin to the general equation is this, right? So I'm just applying the same concept here. So here ax plus by plus cz minus t. So a is 1 by a, b is 1 by b, c is 1 by c, d is minus 1. So I've just applied here. So I've got p to be equal to 1 divided by root of 1 by a square plus 1 by b square plus 1 by c square. I'm finding p square and I'm reciprocating it, right? Okay. Now we also have two ABC planes are drawn parallel to the coordinate plane. So what is this equation of these three planes? Can you say? What is the equation of this line? What is the equation of this line? What is the equation of this line? Very simple, right? So through ABC, planes are drawn parallel to the coordinate plane. So obviously this is a diagram. So what are these three equations? Very simple. This is nothing but x is equal to a. This is nothing but y is equal to b. This is nothing but z is equal to c. So these are the three equations, right? So the equation of plane. So it is given that. So it is given that through ABC, through ABC, the planes are drawn parallel to the coordinate plane, right? Planes are drawn parallel to the coordinate plane. So the equation of plane parallel, the equation of plane parallel to the coordinate plane and passing through the vertices a comma b comma c is given by. So therefore, the equation of plane, the equation of plane to A, B, C, right? So A is A comma 0 comma 0, B is 0 comma B comma 0, C is 0 comma 0 comma C. Equation of plane through ABC and parallel to the coordinate plane and parallel to the coordinate plane and parallel to the coordinate plane is given by R. What are those planes? X is equal to A, Y is equal to B, Z is equal to C. Yes or no? This is nothing but X is equal to A, this y is equal to b. Why? Because this point is 0 comma b comma 0, so it is passing through b, and this is z is equal to c, right? Because this point is z is equal to, this point is passing through c, right? So therefore x is equal to a, y is equal to b, z is equal to c is the equation of plane passing through ABC and parallel to the coordinate plane. So that's it. Call this as 3, call this as 4, call this as 5, right? So eliminate ABC from the equation 2, 3, 4, 5, you will get the required locus, right? So eliminate ABCD, eliminate ABC, eliminate A comma B comma C from the equation 2, 3, 4, 5. Very easy to eliminate, right? Because we can easily eliminate by just putting A to be equal to X, B to be equal to Y, Z to be equal to C. So substitute 3, 4, 5. Substitute 3, 4, 5 in equation number 2. So we have 1 by p square is equal to 1 by a square plus 1 by b square plus 1 by c square. So we know a is x, b is y, c is z, right? So we can easily eliminate this a, b, c. So we have 1 by x square plus 1 by y square plus 1 by z square is equal to 1 by p square. This is same as x power minus 2 plus y power minus 2 plus z power minus 2 is equal to p power minus 2 is the required locus. What we need to prove, right? Through ABC, planes are drawn parallel to coordinate plane. Show that the locus of the intersection is, that is, this x comma y comma z will satisfy the equation x power minus 2 plus y power minus 2 plus z power minus 2 is equal to p power minus 2 is the locus required locus of the point Q. Right? That is a point Q will satisfy the equation x power minus 2 plus y power minus 2 plus z power minus 2 is equal to p power minus 2, right? Very, very important problem. So if you understand the single problem, you can do all the problems, right? Okay. Now we'll move on to the second problem. Very simple, right? So you just have to solve. First, you make use of the condition that it is a distance of p from the origin. So make use of that and you form an equation 1 by p square is equal to 1 by a square plus 1 by b square plus 1 by c square. Why I am forming this? Because here we need p power minus 2 means 1 by p square we need. That is why only from p I'm trying to find the value of 1 by p square. After that I'm using the other condition that it is passing through ABC and parallel to the coordinate plane. So from this you eliminate ABC, you can get the required answer. Right? Very simple. I'll move on to second problem. So again it is similar to the first problem. There is only one minor change, right? A variable plane passes through a fixed point alpha comma beta comma gamma and meets the axis of reference in ABC. Show that the locus of the point of intersection of the plane through ABC parallel to the coordinate plane is alpha x power minus 1 plus beta y power minus 1 plus gamma z power minus 1 is 1. Only difference is here they have said that the distance between the plane and the origin is p. Yes or no? The distance between the perpendicular distance between the origin and the plane is p. Instead of this data, here they have said that this plane is passing through the point alpha comma beta comma gamma. That is the only difference between problem 1 and problem 2. Right? Remaining thing, everything is same. So here we have used the data that it is at a distance of p from the origin. So we have got p to be equal to this and we have squared it and then we have put 1 by p square and so on. So instead of this entire data, they have said that this plane is passing through the point alpha comma beta gamma gamma. That is the only difference, right? Okay. Now we'll draw the diagram. So a variable plane passes through the point. So I'm just drawing a very, very rough diagram just to give you a clarity. Because in exam point of view, if you read by diagram, it will be easy for you to do the problem rather than just mug up in just doing the problem, right? Okay. So this very rough diagram, right? This is an exact diagram because I'm drawing this in 2D surface. Okay. So let us draw, this is a coordinate axis, x-axis, y-axis and z-axis. Now okay, let us draw a coordinate plane. Okay, let us draw a coordinate plane. So let this be, you can see it meets the coordinate axis in the ABC, that is same as axis of reference. So it meets the axis at A, B and C, right? So that the locus of that point of intersection of that planes through ABC parallel to the coordinate plane. So we need to draw a plane that should be passing through A comma B comma C and parallel to the coordinate plane. That is same as previous, right? So we'll draw this. Again, I'm just drawing very, very rough diagram just to give you an clarity, right? So passing through this point parallel to the coordinate plane, passing through this point and parallel to the coordinate plane, passing through the point and parallel to the coordinate plane. This is the point of intersection, right? So let this Q be x comma y comma z. Now in the previous problem, they have said that what they have said, the distance between the origin to the plane is p. Here they have simply said that this plane is passing through the point alpha comma beta comma gamma. That's it. You can yourself do this now, right? So instead of giving the data that it is the perpendicular distance from origin to the plane is p, you have said that this plane is passing through the point alpha comma beta comma gamma. Now we need to show that this x comma y comma z satisfies this equation. The previous problem we have what? X power minus 2 plus y power minus 2 plus z power minus 2 is equal to p power minus 2, right? Here x power alpha x power minus 1, beta y power minus 1, gamma z power minus 1 is 1. Actually very, very easy problem. So let the equation of variable plane, be x by a plus y by b plus z by c is equal to 1. Right? Call this as equation number 1. Right? It meets the coordinate axis. I'm just writing the same thing, right? It is given that it meets the coordinate axis in a comma b comma c. It meets the coordinate axis or axis of reference, right? Coordinate axis in a comma at a comma b comma c respectively, at a b and c. Now what is the vertices of a b c? Clearly we have we have said the equation of variable plane is x by a, y by b, z by c is 1, and you can see x intercept is a, y intercept is b, z intercept is c, right? So clearly the vertices are a b c are given by so A is A comma 0 comma 0, B is 0 comma B comma 0, C is 0 comma 0 comma C, right? C is 0 comma 0 comma C, right? Super. So we have A to be A comma 0 comma 0, B to be 0 comma B comma 0, C to be 0 comma 0 comma C, right? Okay. How we got these 3 points? Very simple, right? If you want to find those points, right? You just put you just put y is equal to 0, z is equal to 0, right? If y is 0, z is 0, this will be 0, this will be 0. So we have x by a is equal to 1. So we have x is equal to a. That means a comma 0 comma 0 is first point. Now similarly, you put z is equal to 0, x is equal to 0. So z is 0, this will be 0, this will be 0. Sorry. Z is 0, x is 0, this will be 0, this will be 0. So we have y by b is equal to 1. So we have y is equal to b. Therefore, 0 comma b comma 0 is y intercept. Now to find z intercept, you put x is equal to 0, y is equal to 0. You will have z to be equal to c. The x intercept, y intercept, z intercept, which are these three. Right? Or else you can easily see, we know that if x by a plus y by b plus z by c is equal to 1, this is the equation of an intercept form. This is x intercept, this is y intercept, this is z intercept. So x intercept is a, y intercept is b, z intercept is c. Right? Okay. Therefore, this point is a comma 0 comma 0. This point is 0 comma 0 comma c, and this point is 0 comma b comma 0. Right? Super. Now, the previous problem, what we did is we have used the condition that it is a distance of p from the origin. Now, what we're going to do is, it meets the coordinate axis. Now, it is given that I'm going to use the condition that it is passing through the point alpha comma beta comma gamma. So, equation 1, this is equation 1, right? This is a plane passes through the point alpha comma beta gamma gamma. That means what? This will satisfy the equation, right? If you put x is equal to alpha, y is equal to beta, z is equal to gamma, this will satisfy the equation. So we have alpha by a plus beta by b plus gamma by c is equal to 1. Call this as equation number 2. So the previous problem, we have called this as equation number 2, which we have got from the data that it is the distance of p from the origin. Right? Now we have got equation number 2 very easily. Now, they have said that we need to equation of plane passing through a comma b comma c and parallel to the coordinate plane, right? For the locus of that point of intersection. Okay. The equation of planes passing through a comma b comma c and parallel to the coordinate plane, right? And parallel to the coordinate plane is given by very simple, right? This point is a comma 0 comma 0. So those equations are given by x is equal to a, 3, y is equal to b, this is 4, z is equal to c, this is 5. Right? Now eliminate a b c. Right? We need to eliminate a b c, right? Eliminate a b, same as previous, right? Eliminate a b c from equation 2, 3, 4, 5, right? 2, 3, 4, 5. Very simple. We have done it. That's it, right? So we have from 2 we have alpha by a plus beta by b plus gamma by c is 1, right? We need to eliminate a, b, c, and we know a is x, right? A is x and b is y. Gamma by c is z is equal to 1. This is by 2 by 3, 4, 5. By 3, 4, 5, right? By 3, 4, 5. By 3, 4, 5. So that's it, right? So you just bring this x to the numerator. So we have x power minus 1 plus beta into y power minus 1 gamma into z power minus 1 is equal to 1 is the required locus of their point of intersection. That's it, right? Actually, problem 1 and 2 are very similar. We have got equation 2 with this data. Now we have got equation number 2 very easily. It passing through the point alpha, gamma, beta, gamma, gamma. Right? We need to eliminate this ABC, which we can easily eliminate by putting A to be equal to X, B to be equal to Y, C to be equal to Z. So just bring this all X, Y, Z to numerator. Yeah, we will get this equation. Right? So far we have done 2 problems. Now move on to third problem now. Right? So third and fourth problem are very similar and very important problem as well as very interesting problem. So we just go through this, right? So solution, a variable plane is at a constant distance 3p from the origin. That is a distance between, whenever say the distance, you just take that as perpendicular distance, right? The perpendicular distance, a variable plane is at a constant distance 3p from the origin. That is a perpendicular distance from origin to the plane is 3 times p, right? Okay. And meets the axis in A, B, and C. Prove that the locus of the centroid of a triangle is x power minus 2 plus y power minus 2 plus z power minus 2 is equal to p power minus 2, right? Very interesting. The previous problem, they have said that through a comma b comma c, through a comma b comma c, a plane is passing and parallel to the coordinate plane. Here they haven't said any data about that, right? So only we have a triangle, only we have a plane, and the distance between the plane and the origin, the perpendicular distance between the plane and the origin is 3p, right? And it meets the coordinate axis in ABC, right? It meets the coordinate axis in ABC. Prove that the locus of the centroid of a triangle is this, right? Okay, let us draw the diagram, then you will have more clarity. So let us draw axis and y axis and z axis. Let this be x axis, let this be y axis, and let this be z axis. A variable plane. Okay, let us draw a variable plane now. Right? You can see it meets the coordinate axis at A, B, C respectively, right? Okay. Now you can see this ABC is a triangle, right? This ABC is a triangle. Now we need to prove that the locus of centroid of a triangle ABC. Now what is centroid? We know what is centroid, right? The point where the three medians intersect, right? Medians. You can see, let us say this is one median, right? And let's say this other median, right? Let's say this other median, and let's say this other median. Hence this is centroid, right? This is a centroid, right? Let this be the point Q, right? Let Q be the centroid. Now we need to show this point, this Q, x comma y comma z satisfies this locus. That is x power, the locus of that point is x power minus 2 plus y power minus 2 plus z power minus 2 is equal to p power minus 2. Remember, depending upon the value of p, the centroid will change, yes or no? For example, if I take p to be equal to 1, that means what? The perpendicular distance between the origin and the plane is 3. If I take p to be equal to 2, that means what? The perpendicular distance between the origin and the plane is 6. Right? If I take p to be equal to 3, that means what? The perpendicular distance between the origin and the plane is 9. That means if I vary p, the perpendicular distance between origin and the plane will vary. Right? Yes or no? Yes. So depending upon p, your q will also vary. Right? The q point will also vary. So even though q point may vary, those set of coordinates of q will satisfy an equation. What is that equation? Is x power minus 2 plus y power minus 2 plus z power minus 2 is equal to p power minus 2. Can you get my point? Locus, you know locus, right? Locus is set of points satisfying some equation. That is called locus, right? So here, depending upon the value of p, the point q will vary. So even though q may be different, the coordinates of all those q, they satisfy the equation x power minus 2 plus y power minus 2 plus z power minus 2 is equal to p power minus 2, right? For example, if you take p to be equal to 1, then it will satisfy x power minus 2 plus y power minus 2 plus z power minus 2 is equal to 1 power minus 2. If you take p to be equal to 2, then it will satisfy x power minus 2 plus y power minus 2 plus z power minus 2 is equal to 2 power minus 2. Can you get my point? So in general, if it is at a constant distance 3p means it will satisfy this equation. Okay, so we'll do this. So let the variable plane be. So let the variable plane be x by a plus y by b plus z by c is equal to 1, right? Now it meets the coordinate axis in ABC. It meets the coordinate axis. It meets the coordinate axis in A, B, and C, right? So clearly the vertices of ABC are clearly, so A is A comma 0 comma 0, and B is 0 comma B comma 0, and C is 0 comma 0 comma C, right? Because x intercept is A, y intercept is B, z intercept is C. This is an equation of linear intercept form. Therefore, this point is A comma 0 comma 0. This point is 0 comma B, sorry, 0 comma 0 comma C, and this point is 0 comma 0 comma B, right? Okay. So far, for all two problems we have done, right? Now, in the first problem, you are using the data that it is at a distance of p from the origin to the plane. Now, here they have said that it is at a distance of 3p from the origin, right? Okay, so we'll use this data. So it is given that it is at a distance of 3p from the origin, right? That is the plane, right? It is a distance of, so you use this data. So given that it is given that the perpendicular distance between origin to the plane, x by a plus y by b plus z by c minus 1 is equal to 0 is 3 times p, right? So we know the formula for perpendicular distance, right? So that means perpendicular distance is given by perpendicular distance between origin and the plane, right? So we know the formula. The perpendicular distance between origin origin to the plane ax plus by plus cz plus d is equal to 0 is given by minus d divided by root of a square plus b square plus c square. Now here they have said that the perpendicular distance is 3p. That means 3p is equal to minus of, so what is a? So just compare ax plus by plus cz plus d. So d is minus 1 divided by root of a square plus b square plus c square. So this is 1 by a square plus 1 by b square plus 1 by c square. Yes or no? So or else you can just write this in a general equation of plane, right? So ax plus by plus cz plus d is equal to 0. So you can just write that in that pattern. So we have ax plus by plus cz plus d is equal to 0. So we have a to be equal to 1 by a, b to be equal to 1 by b, c to be equal to 1 by c, d to be equal to minus 1, right? Okay. So that means we have, so if I square it, we have 9p square is equal to 1 divided by 1 by a square plus 1 by b square plus 1 by c square. So if we reciprocate, we have 1 by 9p square is equal to 1 by a square plus 1 by b square plus 1 by c square, right? Call this as equation number 2. Now, um, now you can see you can just compare and study all the problem, right? In the first problem, they have given the perpendicular distance between origin and the plane is P. So we have got same here in terms of P, we have written 3P now, right? So therefore we have 1 by 9P square is equal to 1 by A square plus 1 by B square plus 1 by C square. After this, in first problem, what we did is they have said that they have said that the planes are drawn parallel to the coordinate planes passing through A, B, C. So we are using this data. We have got 3, 4, 5 here. But here they haven't said that it is planes are drawn parallel and passing through A, B, C to coordinate plane. They haven't said any data. But what they have said is we need to prove the locus of centroid of triangle ABC, right? So let Q of x, y, z be the centroid of triangle A, B, C. Let Q of x, y, z be the centroid of triangle ABC, right? That means what is the centroid of triangle A, B, C? If you know all the vertices, the centroid of ABC is given by x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3, z1 plus z2 plus z3 divided by 3. Right? This is centroid formula. Now here, what is x1, y1, x1, y1, z1, x2, y2, z2, x3, y3, z3? Very simple. We know vertices, right? So A is a, 0, 0. B is 0, B, 0. C is 0, 0, C. Right? So this is our x1, y1, z1, x2, y2, z2, x3, y3, z3. And we know centroid is x, y, z by our assumption. This will be equal to a plus 0 plus 0 divided by 3, 0 plus b plus 0 divided by 3, 0 plus 0 plus c divided by 3, right? So therefore, we have x, y, z to be equal to a divided by 3, b divided by 3, c divided by 3. So if we equate this, we will have x to be equal to a by 3, y to be equal to b by 3, z to be equal to c divided by 3. This implies a is equal to 3x, b is equal to 3y. Let us write this in a is equal to 3x, b is equal to 3y, c is equal to 3z. Right? Call this as 3, 4, 5. You can see the difference, right? The first problem, we are using this as 3, 4, 5. We have written directly because we know the equation of parallel planes, right? Here, instead of that, they have given centroid is, we know all three vertices. Centroid, I assume that x, y, z is centroid. We know all the vertices of triangle. Centroid we can easily find with the formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 divided by 3, right? So we have got a to be equal to 3x, b to be equal to 3y, c to be equal to 3z. Eliminate A, B, C from 2, 3, 4, 5. You'll get the answer. Right? Eliminate A, B, C from equation 2, 3, 4, 5. You'll get the answer. We can easily eliminate A, B, C. We already know A in terms of X, B in terms of Y, C in terms of Z. You substitute this A, B, C in equation number 2. Right? So from 2, we have 1 by a square plus 1 by b square plus 1 by c square is equal to 1 by 9b square. We just replace a to be equal to 3x. So we have 1 by 3x whole square plus 1 by 3x whole square. B is 3y, right? So 1 by 3y whole square plus 1 by 3z whole square is equal to 1 by 9b square, right? So just reciprocate, you'll get the required locus, right? So if not, what you can do is you just take this 1 by 9 outside, right? So here we have 1 by 9x square plus 1 by 9y square plus 1 by 9z square is equal to 1 by 9b square. So take 1 by 9 outside and cancel it out. So cancel it out. So you will have, so we take this 1 by 9 outside. So we have 1 by x square plus 1 by y square plus 1 by z square is equal to 1 by 9, 1 by 9p square, 1 by 9 into 1 by p square, right? So this 1 by 9 will get cancelled. So reciprocate this. So this implies x power minus 2 plus y power minus 2 plus z power minus 2 is equal to p power minus 2 is the required locus. Right? Is the required locus. That's what we need to prove, right? Prove that the locus of center of triangle ABC is x power minus 2 plus y power minus 2 plus z power minus 2. So you can easily, this is easy, right? How we found these vertices? These are nothing but x-intercept is A, y-intercept is B, z-intercept is C. If not, if you want to find the coordinate of this point, you put y is equal to 0, z is equal to 0. If y is 0, z is 0, this will be 0, this will be 0. So we have x by a is equal to 1. That means we have x is equal to a. So that means this point will be a 0, 0. You want to find the coordinate of this point, that is y-intercept, you put x and, this is 0 comma b comma 0, 0 comma b comma 0. So if you want to find this point, so you just put, if you want to find the coordinate of this point, you just put x and z to be equal to 0. You find y, you will get y to be equal to b, right? It's a very simple problem. Now, problem 3. Understand problem 3. Problem 4 is very, very simple, right? Same problem. Instead of 3p distance from the origin, the fourth problem is it is a distance of p from the origin, right? Very same problem. Prove that the locus of centroid of triangle ABC is x power minus 2 plus y power minus 2 plus z power minus 2 is equal to 9 times p power minus 2, right? Okay, we'll do this. So a variable plane is at constant distance p from the origin. Everything is same. Only thing is instead of 3p, here we have 3. Okay. Let's draw the coordinate plane. This is our x-axis, and this is our y-axis, and this is our z-axis, right? So we'll draw a variable plane. Okay. So it meets the coordinate axis at A, B, and C respectively, right? Now you need to show the locus of centroid of triangle is, let us say this are one altitude, let us say this other altitude or median, and let us say this other altitude or median. This is centroid of triangle. So let this be Q be the centroid. Let's call it as x comma y comma z, right? I'm going to follow the same method as in the previous problem. So let us write the same thing, right? So let the variable plane be. So let the variable plane be x by a plus y by b plus z by c is equal to 1, right? Call this equation number 1. It meets the coordinate axis. It meets the coordinate axis in A, B, and C respectively, right? That means what is the coordinate of A? It is A comma 0 comma 0. B coordinate is 0 comma B comma 0. 0 comma 0 comma C, because these are the intercepts which you can found by putting, if you want to find x intercept, you put y and z to be equal to 0. So we have x by a is equal to 1, that means x is equal to a. If you want to find a y intercept, you put x and z to be equal to 0. So we have y by b is equal to 1, that means y is equal to b. If you want to find z intercept, you put xy to be equal to 0. So this will be 0, this will be 0. So we have z is equal to c, right? Therefore, this point is a comma 0 comma 0. This point is 0 comma b comma 0. This point is 0 comma 0 comma c, right? I'm going to write the same. I'm going to write the same thing. It is given that the perpendicular distance between origin to the plane is, here it is 3p. Now here it is p, right? It is given that. Okay, I write it directly. Perpendicular distance between origin 0 comma 0 comma 0 to the plane ax plus by plus cz plus d is equal to 0, right? So here is a is 1 by a, b is 1 by b, c is 1 by c, d is minus 1 is d, right? That means, so d is equal to, we have, so d, sorry, p, right? Sorry, is p. So we have p is equal to, we know the formula for perpendicular distance is minus d divided by root of a square plus b square plus c square. So here d is minus 1. Here d is minus 1. And the a, b, c are 1 by a, 1 by b, 1 by c. So we have minus of minus 1 divided by root of 1 by a square plus 1 by b square plus 1 by c square. So p square will be 1 divided by 1 by a square plus 1 by b square plus 1 by c square. So this implies 1 by p square is equal to 1 by a square plus 1 by b square plus 1 by c square, right? So call this as equation number 2. Same, right? In the previous problem, we have got 9p square because we have 3p. The square it, we have 9p square. Here we have only 1 by p square, right? Okay. Now what we did in the previous problem after this, let q x comma y comma z be the centroid of the triangle ABC, right? That means Q, that is x comma y comma z is given by the coordinate of x comma y comma z is given by x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3, z1 plus z2 plus z3 divided by 3, right? So here ABC coordinates are a comma 0 comma 0. So B is 0 comma B comma 0. C is 0 comma 0 comma C. Therefore, this will be a plus 0 divided by 3. 0 plus B plus 0 divided by 3. 0 plus C divided by 3. So we have x is equal to a by 3. Y is equal to b by 3. This is same as previous, right? So this implies a is equal to 3x, b is equal to 3y, c is equal to 3z. Eliminate ABC. Let us call this as 3, 4, 5. Eliminate A, B, C from equation 2, 3, 4, 5. So from 2 we have 1 by a square plus 1 by b square plus 1 by c square is equal to 1 by p square, right? Let's put a to be equal to 3x. So this will be 1 by 3x whole square. And we know b is 3y and we know c is 3z is equal to 1 by p square. This is same as 1 by 9x square, 1 by 9x square plus 1 by 9y square plus 1 by 9z square is equal to 1 by p square. So if we reciprocate, we will have this. Let us take this 1 by 9 to that side, right? If we take this 1 by 9 to that side, so we will have 1 by 9, 1 by x square plus 1 by y square plus 1 by z square is equal to 1 by p square. So we have 1 by x square plus 1 by y square plus 1 by z square is equal to 9 by p square, or I can also write this as x power minus 2 plus y power minus 2 plus z power minus 2 is equal to 9 times p power minus 2 is the required locus of Q, where Q is the center of triangle ABC, right? So it is a distance of P. So depending upon the value of P, the point Q will vary, right? Even though coordinate may vary, the coordinate x comma y comma z will satisfy an equation. All those x comma y comma z, right, will satisfy an equation. Which equation x power minus 2 plus y power minus 2 plus z power minus 2 is equal to 9 times p power minus 2, right? Very simple problem. So problem 3 and problem 4 are very same problem. Here it is a distance of 3p. Here it is a distance of p. Right? Now we'll do fifth problem and then we'll wind up this video. After that, we will do sixth and seventh problem in the next class. Right? Yes. Okay. Now we'll do fifth problem. Again, very similar to the previous problem. Only thing is, in the previous problem, we have found the locus of centroid of the triangle ABC. Right? Here we're going to do find the centroid of the tetrahedron OABC, right? Very similar problem. I'll do this very interesting and very easy problem, right? Okay. A variable plane is at a constant distance p from the origin and meets the axis in ABC respectively. Prove that the locus of centroid of a tetrahedron OABC is x power minus 2 plus y power minus 2 plus z power minus 2 is 16 times p power minus 2, right? Very simple. So what we have is, so we have a coordinate plane, right? Let this be an x-axis, y-axis, let this be z-axis, right? So we will draw a variable plane. Right? So we'll draw a variable plane. So it meets the axis at A, B, C respectively. Now, this is the origin, right? This is the origin. Now we can see, if you see ABC, it is a triangle. If you see OABC, it is a tetrahedron. Yes or no? You see only as A comma B comma C, it is a triangle. If you see this as OABC, it is a tetrahedron, right? So if you see this as OABC, it is a tetrahedron, right? So you can see it is a tetrahedron. Yes or no? The tetrahedron, right? Now we can see this is 3 dimension, right? It's a tetrahedron. Now we need to show the centroid of this tetrahedron, right? We need to show the locus of the centroid of this tetrahedron is x power minus 2 plus y power minus 2 plus z power minus 2 is equal to 16 times p power minus 2. Right? Very simple. We know center of triangle is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. What is center of tetrahedron? Very simple. x1 plus x2 plus x3 plus x4 divided by 4, y1 plus y2 plus y3 plus y4 divided by 4, z1 plus z2 plus z3 plus z4 divided, sorry, z1 plus z2 plus z3 plus z4 divided by 4. That's it, right? We're going to do same as previous problem. Let us write the same thing, right? Why? Because it is also at a constant distance of P from the origin. That is the plane. The distance between plane and the origin is P, right? So always take that to be perpendicular distance. So let the variable plane be, let the variable plane, let the variable plane be x by A plus y by B plus z by C is equal to 1, right? It meets the coordinate axis. It meets the coordinate axis at A, B, and C respectively. That means it meets axis ABC respectively. That means it meets x-axis at A, y-axis at B, z-axis at C. Clearly, the coordinates of A, B, C are, what is A? A is A comma 0 comma 0, B is 0 comma B comma 0, C is 0 comma 0 comma C. Right? This point is A comma 0 comma 0. This point is 0 comma 0 comma C. This point is 0 comma E comma 0, and this origin 0 comma 0 comma 0. Right? Now, it is at a perpendicular distance between plane and the origin is P. Right? So we'll do the same thing. What we did here, perpendicular distance between origin to the plane is P. Right? Okay. So we'll do this, right. We'll do the same thing. The perpendicular distance. Okay. The perpendicular distance between origin to the plane. What is the plane here? AX plus BY plus CZ plus D is equal to 0. So A is 1 by A, B is 1 by B, C is 1 by C is what? Is P. So we know perpendicular distance is P. The formula is minus D divided by root of A square plus B square plus C square. And here D is minus 1 divided by root of A is 1 by A. So A square, B is 1 by B, C is 1 by C. This is a general formula. Here A is 1 by A. Here A is 1 by A, B is 1 by B, C is 1 by C, and D is minus 1, right? AX plus BY plus CZ plus D. I think you're getting my point, right? AX plus BY plus CZ plus D is equal to 0. So A is 1 by A, B is 1 by C, C is 1 by C, D is minus 1, right? This is general formula for general formula. In this, I'm substituting the value of ABC to be 1 by A, 1 by B, 1 by C, and D to be equal to minus 1. So this implies, what about the value of B square? Implies the value of B square is 1 divided by 1 by A square plus 1 by B square plus 1 by C square. This implies 1 by B square is 1 by A square plus 1 by B square plus 1 by C square. Call this as equation number 2. Right? This is equation number 1. Up to this is same as the previous problems, right? Now, here we need to, in the previous problem, we need to show the locus of centroid of triangle is this. Now we need to find the locus of centroid of tetrahedron, right? So let Q of x comma y comma z be the centroid of the tetrahedron OABC, right? OABC is tetrahedron. So it's a tetrahedron of tetrahedron. So this x comma y comma z is given to be x1 plus x2 plus x3 plus x4 divided by 4, y1 plus y2 plus y3 plus y4 divided by 4, z1 plus z2 plus z3 plus z4 divided by 4. This is centroid of the tetrahedron, right? So here O, A, B, C, right? So O is 0, 0, 0. A is A, 0, 0. B is 0, B, 0. C is 0, 0, C. So this is our x1, y1, z1, x2, y2, z2. And this is x3, y3, z3, x4, y4, z4. So substitute here. We will have this to be 0 plus a plus 0 plus 0 divided by 4, 0 plus 0 plus b plus 0 divided by 4, 0 plus 0 plus 0 plus c divided by 4. So this implies we will get x to be equal to a by 4, y to be equal to b by 4, z to be equal to c by 4. This implies a is equal to 4x, b is equal to 4y, c is equal to 4z. Call this as 2, 3, 4, sorry, 3, 4, 5, right? 3, 4, 5. Call this as 3, 4, 5. Eliminate ABC, eliminate ABC from the equations 2, 3, 4, 5, right? Eliminate ABC from the equation 2, 3, 4, 5. Eliminate A, comma B, comma C from 2, 3, 4, 5, right? So from 2, we have 1 by A square plus 1 by B square plus 1 by C square is 1 by P square. And we know A is 4x. So this will be 1 by 4x whole square, 1 by 4y whole square, 1 by 4z whole square is equal to 1 by p square. So just take this 1 by 4 square outside. So we have 1 by x square plus 1 by y square plus 1 by z square is equal to 1 by p square. So therefore, this will be 1 by x square plus 1 by y square plus 1 by z square is equal to 16 divided by p square. Take a 16 on that side. This implies x power minus 2 plus y power minus 2 plus z power minus 2 is equal to 16 times p power minus 2 is the required locus of q, right? So this q centroid will satisfy the equation x power minus 2 plus y power minus 2 plus z power minus 2 is equal to 16 times p power minus 2, right? So very easy. All 5 problems are very, very important. So all are very similar problems. That is, so depending upon the value of p, the coordinate of q will change, right? So even though coordinate may change, the coordinate x comma y comma z will satisfy an equation which is x power minus 2 plus y power minus, all the coordinates of q will satisfy the equation x power minus 2 plus y power minus 2 plus z power minus 2 is equal to 16 times p power minus 2, right? So in this class, what we have seen is we have solved 5 problems. So all are very similar problems. So problem 1 and problem 2 are similar, and 3, 4, 5 are similar, right? In problem 1 and 2, we have given that through a comma b comma c planes are drawn parallel to the coordinate plane. From that we have got equation number 3, 4, 5 as x is equal to a, y is equal to b, z is equal to c. From that we have eliminated ABC, right? In 3, 4, 5 we have said the centroid of triangle. Centroid, they have given the centroid, right? For that we have used the centroid formula and tetrahedron formula for problem number 5, right? All are very, very easy problem. Just go through, just do the problem once again, right? So it is a distance of P from the origin. So you will get equation number 2 here. It is a distance of P from the origin. Get equation number 2 here. Now in the first problem, it is given that it is a distance of P from the origin, right? So we'll get the equation here, right? All a very similar problem. So go through this video once again. Do the problem. All a very, very easy problem. The next class we'll continue with the 6th problem, right? So we'll do 6th and 7th problem in the next class. and then we'll move on to the next subtopic, right? So we'll see you in the next class. Thank you. All the best.